Recording in progress.
Hello, Professor. My name is Anil Kumar Gumadidala, and my CW ID is 50308836, and my project partner name is Akhil Paramarthi. His CW ID is 50307835. Before diving into deep understanding of the project, what we have done, we want to go through the objective at the beginning, and this is the second slide. Designing a C++ program to simulate an airport, also the landing and departure of the flight on the runway. And inside of the projects are airport has one runway, single runway service, both landing and departure. Only one service runs at a time, either to land or to depart. And this is the objective of the project. And let's go to the introduction. Our process involves simulation and operations of a simple airport. Our airport has one runway that will be used to service both planes landing and departure. The runway can service one plane at a time, either to land the plane or to depart. And we are going to implement threads, mutual exclusion, and semaphores. The main involvement starting and stopping of a simulation along with the statistics such as plane creation, arrival, and departure. And before going into further topics, we want to explain how we use threads, mutual exclusion, and semaphores in the project. And before explanation to the code, we will understand what is threads, mutual exclusion, concurrency, and parallelism, all those topics. Then we will go to the explanation of the code. Threads. First, we will start with threads. Threads is a sequence of instructions that can be executed concurrently with other such sequences in multi-threading environment while sharing a same address space. An initializing thread objective represents an active of execution. Such thread is a joinable, has a unique thread ID. A default construction is a non-initialized thread object is not joinable, and its thread ID is common for all joinable threads. A joinable thread becomes not joinable if moved from or if either join or detach or called on them. And we will see how we working of threads. Using STD, thread is a simple need to create a new thread objective and pass it is callable. A callable is a executable code that we want to execute when the thread is running. So whenever we want a new thread, we just create an object of std_id thread and pass a callable as an argument to its constructor. Once the std thread is object is created, a new thread is launched and the code provided by callable is executed. Next, we see the multiple threads. In a multiple programming operating system, different processes are executing simultaneously. In a similar way, we may want to execute the same process instances simultaneously. Each process instance, in this case, is assigned to a execution unit called thread. And in a multi-threading system, numerous threads execute simultaneously, independent of one another. We'll see the types of multi-threading. Multi-threading is a specialized form of multitasking, and multitasking is a feature that allows your computer to run two or more programs concurrently. In general, there are two types of multitasking: process-based and thread-based. Process-based multitasking handles the concurrent execution of program. Thread-based multitasking deals with concurrent execution of pieces of same program. A multi-threaded program contains two or more parts that can run concurrently. Each part of such program is called thread, and each thread defines a separate path of execution. And while coming to the concurrency, parallelism, semaphores, and mutual exclusion, my friend and project partner Akhil will take from here.
Greetings, Professor. My name is Akhil, and I'm going to continue from here. Let's talk about concurrency and parallelism. Basically, this term concurrency is used mostly in multi-threading process. Basically, we use a single processor or sometimes the multiple processor, but the processor can be switched and execution resources between threads, resulting in concurrent execution will take place. Basically, concurrency indicates that more than one thread is making progress, but the threads are not actually running simultaneously, which means we are having different kinds of threads, and sometimes there are functions where only a particular thread comes into picture. Let's say only one function takes place, and this is nothing but concurrency. And moreover, the switching between threads happen quickly enough that the threads might appear to run simultaneously. That is, within a fraction of seconds, there are like millions of threads or functions running at a time, and we almost feel this way that most of them occur at a time, but they are not. That is why we are using the term called concurrency. In the same multi-threaded process is the shared memory multiprocessor environment. Each thread in the process can run concurrently on the separate processor, resulting in parallel execution. This is where the multi-threading process comes into the picture. Here, the threads or whatever the functions we are executing um, will be executed on a multiple processors simultaneously, and this term is known as parallelism. When the number of threads in a process is less than or equal to the number of processors available, the operating system's thread support systems ensure that each thread runs on a different processor. So basically, while simulating an airport, we need to execute a number of functions. Let's say the arrival, departure, wait time, etc., etc. But all of these operations will run simultaneously on a multiple processors or on multiple systems, and the this results in parallelism. This will save a lot of time as well as gives us a better efficiency and output. Now, with the introduction of multiple cores, as I have discussed earlier, multithreading has become extremely important in terms of efficiency and responsiveness of your application. Basically, multithreading allows us to get the most out of machine by utilizing the maximum uh, input, let's say cores in terms of the machines, or let's say whatever it is. But maximum input is utilized to get out or to bring out the maximum output. Uh, in this courses, so this is all about the concurrency and parallelism. Now let's jump to the term semaphores. Basically, a semaphore is a non-negative variable which can be used to access a common resource of an operating system. Basically, semaphores are used to overcome the critical section problem. The critical section is an area in a program that is used to access common resources. But two programs cannot enter the critical section simultaneously, so semaphores come in handy in such situations. Um, so basically, there are two types of semaphores. We have a binary semaphore and counting semaphore. Um, let's talk about binary semaphore first. Uh, Basically, binary semaphores takes two values, as the word itself describes. It takes zeros and ones, which are nulls and unities. The default value of a binary semaphore is always one. It is also termed as a mutex lock. whereas there is another type of semaphore which is known as counting semaphore. These values may range from 0 to any number, and they have an unrestricted domain. So semaphores solve a critical section problem by using two atomic operations such as wait and signal. Uh, we have two operations like I have discussed, which are wait and signal operation. Basically, a wait operation is nothing but the value of a semaphore, which is either negative or zero. And moreover, no operation is performed or observed. Um, and if the value is positive, if the value of the semaphore is positive, the wait operation is used to decrement. Like we can also describe syntax for the wait operation. Basically, we open a function called wait, and when the semaphore is less than or equal to zero, like when it is negative or less than zero, it is decremented. That is the semaphore functions or whatever it is decremented, which is termed as s minus minus. Same is the case with signal operation, but in a different way. This operation is used to increase the value of the semaphores. Uh, Here is the syntax. Basically, we open the function signal, and since this is a signal operation, the semaphore function will increases. That is the reason why we use the term s plus plus. And this is all about semaphores. Now let's talk about mutual exclusion. This is one of the important topic or one of the important milestone which uh, we used in the program. Basically, mutual exclusion is a property of process synchronization, which states that no two processes can exist in a critical section at any given point of time. Any process synchronization technique being used must satisfy the property of mutual exclusion, without which it would not be possible to get rid of a race condition. And I have also described the syntax of mutual exclusion. Uh, Basically, we use pth words. We usually use pth words, and also there is a term called mutex. Basically, mutex is used to provide synchronization in C++, like we have discussed earlier, which means only one thread can access the object at the same time. By the use of mutex keyword, we can lock our object from being accessed by multiple threads at the same time. In our simulation operation or simulation program, when it comes to, let's say, I need to get the data or I need to know something about arrival of of a particular flight, and if I pull out the thread of that particular function, the other functions related to it might also interfere or might also come into the picture. So to avoid